Hello, everybody. This is your instructor, Mr. Vaccaro. I'm recording this little video clip for you for the purposes of trying to get you guys up to date on what we're going to do tomorrow. Hopefully, you had a nice Labor Day. I'm going to talk about first. Let me get up to the review what we talked about last week. Some of the things we did talk about was conversions. Let me shut this radio off. There's music, when I want to record stuff. Okay, so here's an example of, I guess, what we talked about last week, converting 50 centimeters into inches using the 1 inch is equal to 2.54 centimeters. Let me get this thing in there. But anyway, let's get back over here. So the way to do it is to set up this fraction of 50 centimeters is over 1, and then 2.54 centimeters on the bottom to 1 inch up top. And then as you can see, the centimeters cancel, so these centimeters would cancel and give us inches. And then it would turn into cross multiplication, 50 on the numerator and 2.54 on the denominator, giving us 19.6 inches. So this is some of the stuff that we talked about last week on how to convert on conversions. Another example would be kilograms. I didn't do one of these in class, so if you had something that weighs 93.2 kilograms, how much would that weigh in pounds? Using 1 kilogram is equal to 2.2 pounds. So we set the 93.2 kilograms over 1, multiply it by the conversion of 2.2 pounds is equal to 1 kilogram. So notice I put the kilograms on the bottom so they cancel, and LB is up top. LB is short for pounds. So if we cancel these two out, we get 93.2 times 2.2, which is 205.0. Oops. So basically, we have this as some review for next week, or from last week. Let's see what else we have. Conversions of chapter 5. Write 35,650 into the correct scientific notation. That would be written as 3.5 times 10 to the 4th power. And notice we're between the first two significant figures, and it's 4 places to get there. Same thing here, express 7.5. I'm going to do these in class too, probably all over again, but there are some examples from chapter 5. Let's do, I have some examples from chapter 4. I want to I'll show you those, and we'll do those in class. Now, the new material we're going to talk about are some of the algebraic operations. Finally get into algebra. So, algebra is chapter 6, the basic operations. We're going to talk about vocabulary first. So, vocabulary like coefficients, constants, variables, and so on. So let's talk about those. Vocabulary. Algebra comes from the word algebra, meaning reduction. Diophantus of Alexandria, Greece, in the 3rd century used these early forms of algebra. It's been around for longer than that, actually, but our written language comes from Greeks, the Greek and the Latins, so we use a lot of stories from, we go back to the Greeks a lot of times. Our vocabulary must recognize the following words: constant, variable, coefficient, terms, and expressions. And then there's an equation. For the purposes of what we're going to cover tomorrow, I'm just going to talk about these guys. A constant. Constant is just a number, like 50 or 16. A variable is a letter, like X, Y, or Z. Coefficient is a number in front of the variable. For example, 3x, where the coefficient is 3. And a term consists of a variable or constant. So a term would be 4x, would be one term. 3x minus 1 would be another. Let me see if I can get this on the show page. this. Stand by for a second. Let's see if I can move the, oops, I guess not. Anyway, about the terms. Terms have many examples. Here's an example of a one-term expression, 3x squared. Two-term expression would be x minus 1. A three-term expression would be 3x cubed plus 2x minus 1. And a four-term expression would be 5x to the fourth plus 3x squared minus 2x plus 1. So these are sort of comments about different kinds of terms. Okay. Want that? So, algebraic expressions. By definition, algebraic expression has variables and numbers. For example, in this algebraic expression, 2x plus 1, or 2x plus 3, we want to ask ourselves, is this an algebraic expression? Yeah, sure is. An algebraic expression is a number variable with some operations. By definition, it's an expression with variables and numbers. I probably should say and operations here. Let's talk about like algebraic expressions, terms that are like. Is this an example of two terms that are like in the following expression? 3y plus 1.5y. Are these like? The answer is yes. What about these? X squared minus 2x. No, these are unlike because of the x squared term and the 2x. They have to be, both x squared terms be like. What about this one? Again, we have a y term, a 2y plus 5y squared, unlike terms. And this last one you can barely see is 3z and z. Well, these are like. So let me bring that up a little bit. There we go. 3z and z are like, so we can say those are like terms. The thing about like terms and unlike terms, we can only add or subtract them. So if we're adding and subtracting like terms, we basically, if the terms are the same, then we can add them or subtract them depending on the sign. Like 2x minus 4x. It's going to be equal to minus 2x. 4x squared plus 3x squared. Well, this is going to be equal to 7x squared. It's chopped off a little bit there. I suppose I can bring all this up and we can see it. There we go. This one we have an example 5y plus x minus 2y minus 10x. Notice that we have two types of variables. We have y terms and x terms. So we deal with the y terms first. We don't have to, but we're reading left to right. 5y minus 2y becomes 3y. And then positive x minus 10x is minus 9x. So this is my final answer for this one. So we can add or subtract like terms, even if there's fractions involved. 1/2 of x plus 5y minus 2x minus 15y. 1/2 of x and minus 2x become minus x. And then minus 15y plus 5 is minus 10y. So there's another case for taking the likes. Okay. So we're going to talk about this. We'll do some problems in class. We're also going to talk about exponent rules and exponent notation. I don't want to make this clip too long, so I'm going to give you a little heads up. We're going to talk about 6.3, where we talk about exponential notation. For example, if we multiply 2 to the third power, it's like 2 times 2 times 2, which equals 8. Same thing, 1/3 to the third power is like 1/3 times 1/3 times 1/3 is 127, so on. So we're going to talk about that a little bit. I'll give you a little heads up on that. And then we're going to talk about the exponent rules. There's a bunch of those. I've got 8 of them actually. These are the first two, called the product rule and the product of multiple terms rule. That's the first two. It's third and fourth, raising a product to a power rule. And then we got power to a power rule. We got 3 and 4, 5 and 6. Got the Q rules. Got the Q rule and the Q rule of multiple terms. And zero power rule and the upstairs downstairs rule. So I'll probably stop right there as far as new material goes, but there's about 10 minutes worth of clippage here for you to get a head start on. Look at some problems, look at some sections. Hopefully you'll get this clean enough where you can see it and just work on them before we get there. See you tomorrow. Talk to you soon. Hopefully you enjoyed this. Bye.